Okay, we're doing a little bit of review on solving exponential and solving logarithmic functions for your quiz tomorrow. So I want to just kind of go over a couple of them, then open it up to questions for you from your previous quiz. Okay? Let's say we're going to solve an exponential equation, something similar to this. Looks kind of ugly. But what will be involved when you're solving for variables that are up in exponents? Logarithms. Yep, you'll do logarithms because that's what can get things down out of the exponents. Okay. But before we do any logarithms, what would we want to do first in this instance? Let's subtract the 7. Let's get it to just something raised to a power equals a number. So we want to subtract the 7 from both sides. So I got 4.6 raised to the 2x minus 1 power equals 14. Not quite right on this. Okay. Now at this point, now that I have just one base raised to an exponent equals some number, now is when I would log both sides. Or if you want to natural log both sides, you certainly can, but I just common logarithm both sides. The only time I would probably natural log both sides right now is if it was e raised to a power. Okay? But again, you wouldn't even have to do that. You could just common logarithm still both sides of the equal sign. So I'm going to do log of 4.6 to the 2x minus 1 equals log of 14. Some people might be saying right now, well, couldn't I have just changed forms? Couldn't I have just changed forms from logarithmic form to exponential form? The answer is yes. Okay, that works too. You'll get to the same spot. All right. But the reason I kind of do it this way is because the way I process things here, if I'm trying to solve for a variable that's up in an exponent, by me putting logarithms on both sides and knowing my log properties, that allows me to do what with this exponent? Bring it out to the front. Now it's not up in the exponent anymore, and the problem becomes much easier to solve. So I can bring that entire exponent out to the front. So 2x minus 1 times the log of 4.6 equals the log of 14. I'm going to need some calculator help here shortly, so I appreciate any help I can get to speed things along. Okay? So 2x minus 1 times the log of 4.6 equals the log of 14. Okay? What do you think you do next? I divide both sides by the log of 4.6. Okay? So that would leave me with 2x minus 1 equals, and here's where I need some help. I need to know what the log of 14, close your parentheses, divided by the log of 4.6 is equal to. Anybody?
1.73.
A second on that, anybody?
Yeah, 1.73.
1.73-ish. Okay? Do not round this. I'm going to, here, just for our purposes, but do not round that number. Keep that number on your screen, whatever number that is. And then now to finish off the problem, all you need to do is what with that number that's on your calculator screen? Add 1 and then divide by 2. Okay? Add 1 and then divide by 2. And how about to 4 decimal places? Can somebody give me the answer? 1.3647?
Yeah.
Okay. Now, if I'm the one taking the test tomorrow, I get my answer of 1.3647. I type in 1.3647. I take it times 2. I subtract 1. I take 4.6 and raise it to that answer. 4.6 raised to previous answer. I add 7, and my calculator says 21.00146,226. Did I get it right? Yeah. It didn't equal exactly 21. Why? You rounded it at the end, right? But the fact that I got 21.00, I know I did pretty well. Previous answer button is located on the negative symbol right here. It's ANS. So I just got to go second that. Oh. So like anytime I got, like if I wanted to take, if I wanted to take 5 divided by that answer, 5 divided by previous answer. I'm gonna be able to do that. But you can only use the most previous answer on that. Saves you time as opposed to typing all those numbers back out. So, what questions do you have on solving an exponential function?
So if you change forms,
At this step, if you change forms, okay, I'm with you.
so would you just move that 4.6 like over? So it's like
4.6 is your base. This would be this in logarithmic form.
Okay.
So then you could do this part on your calculator. You know, you could do that on your calculator right here. And that ends up giving you this 1.73 number. Then you add 1 and divide by 2. So it's honestly a little bit quicker, but some people just struggle with changing forms, or maybe they put things in the wrong spot when they do change forms. So that's why I think maybe I did that too when I was younger, and so it just made more sense to me. Okay, my variable's up in the power, so if I just put a log in front of both sides, I know I can bring that variable and get it down out of the power, and I don't need to mess with powers anymore. So, but this would be fine too. Okay? Other questions on this? Okay? Alright. I got another solving, just no relationship to anything, just a random equation here that we're going to solve. It's a logarithmic equation. So the previous one was an exponential equation, this was a logarithmic equation that we could have to solve. Log to the base 3 of some number minus 8 plus log to the base 3 of some number is equal to 2. Solve for x. What do we got to do first here? Yeah, make it one logarithm. It's addition, Burke said, so therefore we can multiply them together. We can multiply the x minus 8 times the x. What is x minus 8 times x?
X squared minus 8.
X squared minus 8x. Very good. So that's what I'm going to write. Log to the base 3 of x squared minus 8x equals 2. Okay? And the reason we want to get it to be just a single logarithm is because now what can we do? Change form. Sorry, Dakota, I cut you off.
What if it was different bases?
You could not then use the log properties if they were different bases.
Is there a way to solve it if they're different?
I do not know off the top of my head. I'm sure there is some sort of. It would have to be. There'd have to be a way to do it. I'd have to somehow change the bases so they were identical.
Oh, okay. Can you log a logarithm?
Sure.
So could you common log both of them?
Yeah. For time purposes, and I'm recording right now, I'm going to move forward. All right. But yeah, I haven't done one like that I can think of, but possibly. What do we do next? Joe, change forms, right? What would we be if we change forms? What do we get? 3 squared equals x squared minus 8x. So 3 squared equals x squared minus 8x. Subtract 9 from both sides, because it's a quadratic equation right now. Anytime you have a quadratic, anytime you have an x squared, you want to set it equal to 0 and hope that it's factorable. Otherwise, you're stuck using the quadratic formula if you can't factor it. Okay? So 0 equals x squared minus 8x minus 9, because 3 squared is 9, and I subtracted 9 from both sides to get it set equal to 0. Is that factorable?
Yeah. X minus 9.
X plus 1.
So x minus 9, x plus 1, so my solutions.
9, negative 1.
Okay, circle my answers, move on to the next problem.
No. Plug 9.
Yeah, make
make sure that one of them works.
And make sure they work. I can tell you right now, one of them won't work.
This would be negative.
Negative right here. Can't take a logarithm of a negative number, okay? Because if you think about it, log to the base 3 of negative 1 means 3 raised to what power is equal to negative 1? Not possible. You can't take a base of 3 and raise it to a power and get a negative number. Okay, so even if you don't recognize that or see that right away, if you try to plug in a negative 1, okay, you're not going to get an answer. It's going to come up error on your calculator. So I know that one's not going to work. We can probably do this in our heads, really. 9 minus 8, 1. What's log to the base 3 of 1?
0.
0. Because 3 raised to what power equals 1? 0. Okay, so the answer to that part is 0. What's log to the base 3 of 9? 2. Because 3 to the second power equals 9. So really I have 0 plus 2, that equals 2, so 9 works. Okay? Questions on a problem like that?
Will you give us one that's in the solutions on the test?
I don't know. Just check them. Just check your solutions. Right? Anything else on a problem like this? Okay, so that was real quick, solving logarithmic and exponential functions, just solving for x. No real story problem to go with it. I'll do some story problems next.